Brilliant. Okay, so yeah, as said, my name is Pete Morris. I'm one of the software developers in the University of Manchester Library. I'm talking today about some of our experiences that we've had putting together AI and using AI in the library itself. And one of the things which is perhaps different from this talk and some of the other ones we've heard today is that we came to this relatively fresh. We're not a specific research team. We don't have any AI expertise in our house. So because of that, we needed quite practical uses, and we were starting from scratch. And as a software developer, I wanted to write code. That's what I do. So because of that, we were really looking to come up with some quite low-level solutions. And so I thought I'd present today some of our lessons learned, as well as some of our achievements, because for many people listening to this talk, they'll have already experienced all of these lessons learned. These are, they're researchers and they know all of this, but I'm hoping that there's some people listening in who are perhaps more less familiar with some of this, and this might help them avoid some of the problems that we encountered. So I've broken down to 6 different things that we've sort of concluded from this. And the first thing above anything is, if you're not working in a research around this, you need a problem before you have a solution. One of the things we found was that there was a real tendency to get FOMO, fear of missing out, around this. And we sort of said, we've got to do AI. It's the next thing after blockchain. So we've got to do AI. We've got to make sure we've got something so we don't miss the boat. And the problem we found with that is that we can come up with all kinds of amazing AI answers, but if we haven't got the problem in the first place, we can't use any of them. So this was something that we really needed to, first of all, explore the technologies, but then actually come up with a use case for it. And related to that, if you're starting with AI from scratch, we found that there was a tendency for a bit of what I'd call woo-woo to creep in. There's a sort of used car salesman aspect of AI can do it. Doesn't matter what it is, we can do it. It's a cure for all. It can solve all the world's problems. And you'll read all these articles around about how it's changing the world. And it is, but it's all, as Sophia mentioned, about pattern matching at the end of the day. It's all about patterns. It's not about magic. And that's something which we really had to learn, quite complex early on. We've been looking at something called feed-forward neural networks, which are very much about patterns, about saying, when we see this, give me that, and so on like that. And it's nothing more than that. It's nothing less than that, but there's no woo-woo involved. And in terms of starting this from scratch, one of the things that I found writing code is that everything is either too simple or too complex. So if you say, okay, well, I want to learn about writing AI, about using AI, you'll find 1,000 guides out there which give you the introduction of, in computer science, what's called an XOR logic gate. And you'll see that example again and again. And you can write the code and it works, and that's fantastic. But it doesn't really have any real world practical applications to that. So once you've done it, you've done it. And then at the other extreme, you'll find that you'll search for an idea and it will come back with very advanced material, which is not necessarily very useful if you're in that middle area. So there's not a lot of middle ground out there, which is something that we found slightly difficult. And again, as a learning exercise, one of the things I've discovered is that less is more. There was a faux pas I made at the start where I assumed that if you have a very large neural network, it will behave much better than a very small neural network. So there was a sort of false assumption in my head that the more processing power and the more RAM and the more I throw at this, the better the results will be. And actually, for many of the problems we were doing, they didn't need that. And it's kind of like if you have an awful lot of brain power to crack a really small problem, you start second guessing yourself and you start overthinking the problem. And so you end up with getting the wrong answer because you fly off in different directions. So because of that, we learned that actually for some things, less is more. And similarly, around that, Sophie mentioned as well about massaging the bias that you can get. I found that there's a tendency to massage the input data too much, where you think, well, perhaps if we remove that bad example, perhaps we remove that bad example. And sometimes you massage it so much that you introduce your own human bias into it, and then it doesn't produce good genericized output from that. On the flip side of that, small changes can make a very big difference. We found that if you tweak your data, one of the things I encountered is sorting versus unsorted. This wasn't obvious to me. Things like TensorFlow and Brain.js and stuff like that. If you give them sorted data, they behave really badly. If you randomize the data before it goes in, they behave very well. I don't fully understand why that is, and I'm sure there are experts on this call who can probably tell me, but it's that little small tweak of learning that if you have exactly the same data, but you randomize it before you put it in, you get completely different answers out of it, and often those answers are much better. Tweaking learning rates, loss optimizers, number of epochs as well. We again assumed that if you trained something for 5 years, it would produce better results than if you trained it for 5 minutes. Turns out not so. For some things it probably does, but not for everything. Sometimes the more you train something, the more it starts to again second guess itself. And the last thing which we found was that some parts of AI are very opaque, but also some parts are very transparent. Certainly a lot of the neural network work I was doing was particularly opaque. The whole point is about the machine trying to learn itself how to do things based upon examples I give it. But we found another one, a system called a priori, which is an algorithm-based one, and that you can find the algorithm online. It's pseudocode, and it's very, very simple, but we actually found it was very effective. So to use this as an example, in the bottom right hand of the screen, we've got a kiosk that we put together, which uses a priori to look at all the thousands and thousands of student books that are checked out by all of our students at the university and spots mappings and pairs. It spots triplets. So if we've got multiple people checking out the same books, it can start conjecturing reading lists. And we've started to be able to use that to predict the reading lists that people have on their courses before we're actually given the reading list, which is quite fun. And another just a little example we have on the left there. This is one we've used, a very, very simple feed-forward neural network where we've given it various pictures from our collections and just asked it to find colorful ones. So I've programmed it in advance with examples of colorful images and examples of not so colorful images, and then trained that up and said to it, go and find me more colorful images. And although that's a very simple, not particularly advanced concept, for our website, it's fantastic, because it means if you go to the digital collections website, you can see a live attempt of our AI to find colorful images, and then you can vote on that, and that improves the training going forward and so on. So it's a very practical way we've been able to actually put this directly onto our website. So that's pretty much everything I wanted to cover. If anyone's got any questions, I'm very happy to answer at the end. But it was just to mention some of the practical steps that we've come up with and the lessons that we've learned whilst we've been exploring AI for ourselves. So thank you very much.